literally just been collected by my master's students. So I've had this data for about a week. And so there's an awful lot to do with it. I've only really scratched the surface of looking at it. I very much consider this study to be a pilot study, a kind of preliminary testing of the waters to see whether or not this is something worth pursuing further. So one of the things that I kind of quite like to discuss at the end is just, you know, where to go from here. Do I do anything with this? Is this a dead end? I don't know. I'd like to give viewpoints. Okay. Oh, how do I make that advance? Okay. So if you think about a typical kind of eyewitness task, a witness will see some kind of event, will then, you know, some period of time will pass, and they might be shown a lineup that consists of a suspect and some known innocent fillers. And we use our response to that single lineup, if you like, to try to make some kind of probabilistic inference about the likelihood that the suspect is guilty, which might be supplemented by things like confidence or response times or some other thing. But essentially, it kind of boils down to this single one-shot opportunity. Now, I was talking to some of my colleagues who are more kind of basic face recognition researchers in a lab meeting, and they kind of went, well, that's bonkers. Why would you ever do that? Why would you ever base something like that on a single decision from a single instance of a face? So that kind of got me thinking. Faces, of course, vary. They vary in lots of ways over longer periods of time. They vary in hairstyles, in aging, facial hair, you name it. But even over very short periods of time, faces are dynamic. They change in expression, pose, lighting, and so on. And any individual instance of a face is going to look more or less like the kind of memorial representation that we've formed of that face. Some will simply look more like that prototypical image than others. Even someone very familiar like Johnny Depp here, some of these images look more like Johnny Depp than others and will fit our memorial representation of him better than others. So we kind of got thinking, well, what if instead of this kind of one-shot approach, what if you've got your witness, of course they view your event, but then what if we gave them multiple opportunities to try to identify the perpetrator? So what if rather than one lineup, we give them several lineups, all containing images of the same people, but using different images taken at different time points with different lighting and expression and those kind of natural variations that faces have. So that's kind of what we were trying to do with this study. So there is some previous research that has kind of had similar ideas that I'm going to quickly point to. So Pryke et al. In 2004 looked at responses to lineups. They had face lineups, they had body lineups, and they had voice lineups. And they kind of were looking at essentially, does combining those decisions together make for a more reliable decision? So if someone identifies the face and the body, or the face and the voice, is that more diagnostic, if you like, than just identifying the face? And there was some evidence for that, although generally speaking, performance was pretty poor on the body and the voice lineups, which kind of limited its ability to add much information to the face lineup. Similarly, Sowland and Sporer in 2008 ran a study where they had two face lineups, a profile and a portrait, as well as a body and a bag lineup. And again, they looked at kind of combinations. So if people identified the suspect from both face lineups, was that better than a single face lineup, or was face and body better, and so on. So there's some previous research done on this, but we don't know of anything that's kind of just looked at lots of different instances of a face. So that's where we decided to go in. And our question was really this. So if you have multiple lineups for the same suspect, can you predict whether the suspect is guilty? Can you predict essentially whether the person saw a target present or a target absent lineup from the number of times they choose the suspect? And of course, we can also ask the same questions for things like filler IDs or non-IDs. So like I said, this is a bit of a preliminary study. So we tested 192 participants. We had each participant do two trials, giving us a total of 384 trials. About 3/4 of them were recruited through Prolific, and another quarter were through our own participant pool at Swansea. We had various kind of exclusion criteria that we put in place for data quality. So we had some attention checks embedded in there. We asked participants if they had any technical difficulties with the video. As I'll talk about in a minute, we used celebrities from other countries, and so we had questions in there about whether they recognized anybody. And there was also a programming error that we detected and fixed early on that resulted in a few more exclusions. So we ended up with 290 trials. So preliminary, and you'll see when I get to my graphs that it does mean there's quite a lot of noise in here. There's very wide confidence intervals. So yeah, we'll get on to that. Okay, so basically what we did to create our stimuli was we used a paradigm that's been used by, I want to say Mike Burton, what he's called, or maybe Richard Kemp, the local heroes kind of paradigm, right? Where you take minor celebrities who are unlikely to be known outside of their home country. So we chose newsreaders as people who are sort of very unlikely to be known outside of where they're from. And we chose people who weren't from the UK. So we had some Australian newsreaders, for example, and India and various other places. We found a 20-second segment of them speaking directly to camera on YouTube. And we also Google imaged them to find 5 different images of them with variability in expression, pose and lighting. So all 5 of these images here are of the same person, although they actually look really quite different across those 5 instances. It's actually the same person. So we did that for all of our targets. We had 4 targets altogether, 2 female and 2 male. And each participant, as I mentioned, did 2 trials. They did 1 random male trial and 1 random female trial to just avoid sort of interference and confusability. So for each target person, we had 5 different images, and then we created fillers and innocent suspects in the same way. So 5 different images of every filler, 5 different images of every innocent suspect. And the paradigm basically looked very much like a standard eyewitness paradigm, right? They watched the video, they did a filler task. In this case, it was a questionnaire. And then they were randomly allocated to a target present or absent condition. So in a target present condition, they would see a target present lineup. They would make their standard response, pick somebody or say not present. Then they would see another lineup for the same people with the same people in it, just different instances, different images. And they would do that 5 times. So they would see 5 target present lineups. In the target absent condition, they would do the same thing, but now they would have 5 target absent lineups. So all of these would contain the innocent suspect. So just to be really super clear on this, the lineups always contain the same people, and they were always all target present or all target absent. And the participants were told that. So they were told that all 5 images would contain the same people, but shown in a different order. So there are 3 dependent variables that I'm going to focus on today. The first is how many times across those 5 lineups did the witness pick the suspect? And then same thing for filler IDs. How many times across those 5 lineups did they pick a filler, any filler? And how many times did they reject the lineup completely? And our first question really is, how well do those things predict suspect guilt? And what we kind of expected to see is that the more times the suspect is chosen, the more likely it would be that the suspect would be guilty. And we thought that filler IDs and non-IDs might work in the opposite way, that it might increase the likelihood of innocence if you've got more filler IDs or if you've got more lineup rejections. Before we get to that point though, I just want to show you our frequencies of responses. And unfortunately, people's performance was pretty dire. And I'm going to return to this point later on. We spent ages putting these stimuli together. We did mock witness tasks, and we were really surprised when we saw these data because performance was pretty poor. And you can see that overall, the correct ID rate was only about 30% across these 4 lineups. And despite our best efforts, we obviously had kind of somewhat biased target absent lineups as well. These innocent suspects being chosen much higher rates than we would expect by chance. And I just want to draw your attention to these 2 lineups that I've highlighted in red here. I think we've got a bit of a doppelganger problem here. Our innocent suspects are being chosen at pretty much exactly the same rates as our guilty perps. So we've got a floor effect here in the data. We've got basically no discriminability going on here at all. And I think target 4, not only do we have a doppelganger effect, but this correct ID rate is abysmal. So I think we have a stimulus problem here, which is unfortunate because it's the kind of thing you sometimes only know once you've got your data. All right, so we're going to see some graphs that look a bit like this. If you're used to looking at confidence accuracy kind of characteristic graphs, which thankfully several have been presented today already, then you'll know what these look like. What we're going to be presenting here is these will be all of the witnesses who chose the suspect 0 times. And we'll be plotting the probability of guilt here, i.e. what percentage of those trials were target present. And then we're going to do the same thing for all the witnesses who pick the suspect once, twice, 3 times, and so on. Okay, so let's start with suspect IDs. So that's what our curve looked like. So you can see that from as you increase from 0 up to kind of 4 suspect IDs, you get this quite nice increase in the probability that the suspect is guilty. So if the witness never picks the suspect, then he's probably innocent. If they pick them quite very frequently, it's probably guilty. But then there was this kind of weird drop. But I just want to draw your attention to this graph down here, which is the number of, basically the frequencies across these different categories. And what you can see is that we're talking about a very small number of trials up here, which is why this confidence interval is so wide. So this data point is pretty uninformative and very noisy. So what I've done here is I've just collapsed them into 3 different bins. So 0 times, sort of 1 to 3 times, so that's kind of middling, and then 4 times or more. And I think that's a clearer pattern there, that you can see that there's this increasing probability of guilt. Again, though, we're still looking at a relatively small number of trials up here with 4 or 5 suspect IDs. So that's kind of what we sort of expected to see. If we look at filler IDs, this is pretty underwhelming. It's basically flat. There's some, if you collapse them, there's some sort of suggestion here that if they never pick a filler, then your target is probably guilty. If they pick fillers, then your target's probably innocent, but it doesn't seem to matter how many times they pick a filler, as long as it's more than 1. Non-IDs was even more underwhelming. Again, if you kind of bin these, it's pretty much exactly flat. So the number of times someone rejects the lineup really doesn't seem to give us much information at all. We thought that, you know, if someone's consistently saying, no, not there, not there, not there, then it would be a really good indicator of innocence, but just doesn't seem to be the case, which was kind of interesting. Now, if you remember before, I did say there were a couple of our 4 lineups where performance was really, really poor. And so one thing that I was wondering is whether or not this kind of doppelganger effect here is acting as an important moderator. That perhaps we'll see a stronger relationship between the number of suspect IDs and guilt in our easier lineups, these lineups where we actually have some discrimination ability. And when there's basically a doppelganger, it won't be of any use at all. So this is just the data collapsed across the 3 bins, but split across these 2 different targets, and it's stark, right? So here is our lineups where people actually had some discrimination ability, and it's a pretty nice line here, and up here we're getting up to about 90% accuracy, although once again wide confidence intervals because of a small number of trials, and it's basically flat for our doppelganger lineups. So I thought that was kind of interesting and an interesting discussion point. All right, so just to quickly sum up, so there's some sort of suggestion here that multiple suspect IDs do seem to increase the probability that the suspect is guilty. But it does hugely depend basically on how difficult or easy the lineup is, or more specifically, I think it depends on the kind of similarity relationship between the innocent suspect and the target. If you've got a doppelganger, then this kind of cue is useless. And I haven't looked at confidence yet, but I suspect it's going to be the same thing. I think confidence is going to be pretty useless in those kind of doppelganger lineups as well. I'll be interested in looking at that. And basically, to my somewhat surprise, filler IDs and particularly non-IDs just weren't informative. It didn't matter how many times someone rejected the lineup, didn't seem to change the probability of guilt. So that's it from me, really. So I guess my questions, well, unless anyone's got questions they want to ask, some of my discussion points are basically this idea of lineup difficulty, or this kind of doppelganger thing, kind of reminded me of Jim Saw and colleagues' point that they made in a paper recently about the confidence accuracy relationship, that there might be these really important moderators that are actually really difficult to predict when you're making your lineup and quite difficult to measure. That this idea of the kind of similarity relationships might be really important for any of these kinds of cues that we're trying to use to predict the reliability of a witness. And then just sort of, I guess, is this worth doing any more on? Should I invest more resources in this? I don't know. I'm not sure where to go with this now. And that's it for me.
Thank you so much, Ruth. That was brilliant. Really, really interesting. I was scribbling down questions, but I'm trying not to hog the floor. I can see Kay's got her hand up. Kay, do you want to unmute yourself and ask the question? Or
Sure, thanks very much. That was really, really interesting, Ruth. Thank you. It put me in mind of some work that I was doing a wee while ago with Ryan Fitzgerald,
Yeah.
looking exactly at this issue of sort of face variability, within person variability. And so we've done a few experiments now, and I need to go back and look at what we did one that's exactly like what you presented, except we didn't ask them to make the decision at each point. We held the position of each ID in the lineup consistent. So participants were told the person in slot number 1 is going to be in slot number 1 every time. Update your idea yourself and only answer at the end to see if that would, that sort of sequential exposure to variability would help. And we did another version of the same sort of idea with some students of mine interrupting an open day talk and then testing people at the open day. That's such a nifty paradigm that I've nicked from Ryan and you guys that have done some of that stuff. We need to do a more controlled online version of that task. But there what they did was every person either saw a lineup that contained a sequential lineup containing one image of each lineup member, or 6 presented simultaneously but of the different lineup members. And the results were a bit variable, but really we found that presenting multiple images just increased choosing, I think, quite a bit. So when the person was a target present lineup, you were more accurate, but you were also more inclined to choose a filler or the innocent suspect when you were presented with a target absent lineup. So I need to dig that stuff out anyway, but I know that I have some summary reports because we got some money from the EPS to do it. So I've shown them what we did. So would you be interested if I just sent that to you, so you can look at what we've done and see if it's relevant?
Yeah, that'd be really useful. Thank you.
I think it's a really neat idea to say, so does the number of times that they're chosen actually predict the guilt? And we didn't look at it from that point of view at all. So I think that's a really interesting question.
Funnily enough,
it answers the last question, yes.
I was saying, funnily enough, if I do take this further, I was pretty much going to hit up EPS for a little pot of money to do that. So yeah, what you've got would be really useful to see.
Yeah, for sure. I'll send that on to you later on.
Sorry, there's a question in the chat from Colin. Hi, Colin. So yes, we had 4 targets, and yes, we did see different patterns. So hold on, let me just go backwards here. So I've only split this here by, essentially we had these 2 kind of lineups where ID rates were really very poor, and where the innocent suspect was chosen pretty much the same rate as the guilty. And for those guys, it's just a flat line. Nothing's going on there at all. Whereas for the lineups where there's some evidence of discriminability, you do get a much clearer pattern. So yes, there was definitely a change in the patterns across lineups. My feeling is that it's driven by essentially the kind of similarity between the target and the innocent suspect, but it could be anything. So Jamal's asked a question about whether we controlled the types of views within each lineup and did we think it would matter. We went really here for just kind of trying to get as much natural variability as possible. So within reason, as long as the photo was of a reasonably good quality, we just kind of shoved them all in, shuffled them up. So we didn't go for like controlled poses and things like that, partly because we were quite limited in what photos we could actually find of these kind of, quite niche minor celebrities, but also just because we kind of just wanted to see what natural variability kind of does and what it looks like. But I think a next step might be to do something slightly more controlled with different poses that are more systematic or something like that.
Can I just quickly jump in there, Ruth? I've just spoken to the other people in the other sessions and they're running 10 minutes behind. So feel free to carry on with the questions. You're doing a great job. This is amazing.
Ruth?
Yeah.
Take a look at Natalie Calmette's dissertation, because she did some of that. If you can't find it, I will pass it on to you. But she did something along those lines of controlling the specific viewpoint.
Oh, great. I'll have a look at that. Did she not publish that stuff?
No, she hasn't. And I'm not sure she plans to, but I might poke her a bit and ask her about it.
Yeah. Okay, so Renan has a question. In the doppelganger lineups, is the level of similarity something you could expect in real cases? Do you know what? I was floored by this. I really didn't we didn't create these lineups to be doppelgangers. In fact, the way that we created our stimuli, we were really meticulous. So I had a group of project students, and they each went and found a target person. They went and got some mock witnesses to write descriptions of those targets. They swapped descriptions and they found fillers based only on the description. They'd never seen each other's targets. So we weren't choosing our targets or our innocent suspects or anything based on similarity. They really were based on the descriptions. I even went back today frantically looking back through my coding. I thought I'd made a mistake in my data analysis. I was kind of thinking I must have done something wrong here. These data can't be right. I guess so. I mean, if we I don't think they're doppelgangers. I'd love to show you. I should have had a slide up actually to show you what these two targets look like and what their innocent suspects look like. To me, when I just look at them side by side, they're not doppelgangers. They're clearly different people, but obviously there's enough similarity that people are responding to them in that way. But it wasn't something we would have predicted based on our mock witness data at all. So how that speaks to your question here about real cases is, I mean, I guess if it can happen unintentionally in an experiment, then sure, it doesn't seem beyond the realms of possibility that you'd have this kind of situation in the real world. And this is why I think Jim Sorinel's, their paper about, sorry, I'm really rambling, their paper recently about the kind of limits on the confidence accuracy relationship, I think they made some really, really good points there around things like, you know, it is hard to kind of quantify some of these similarity relationships. It's hard to predict them based on things like mock witness data. And this is one of the additional analyses that I want to get stuck into, is looking at the shape of the confidence accuracy curves across the kind of doppelganger and easier lineups, because I suspect that it's going to look a lot like this. I think that confidence is going to be pretty useless for these two lineups here.
Yeah. Can I say one thing, Ruth? I totally agree with everything you just said then. And I guess in real life, how likely the doppelganger innocent suspect is, how likely that is to occur in real life might depend on how the police found that innocent suspect to some extent. So maybe we need to be thinking about that. So if the police find the suspect based on just the witness's description, then yeah, like you said, it should be somewhat chance that the innocent suspect looks more like the real perpetrator than the other lineup members do. But if the police have used another method to identify an innocent suspect, such as CCTV of the real culprit, then that's when you would get a doppelganger in real life. So I think that's another thing that we probably need to consider as well. It's like how that suspect became to be known to the police, for example. Yeah, sorry, that was also rambling. You've got
no. I'm sure I've read some stuff on that as well. I'm trying to remember, but there have been some papers I think that have made that argument about this idea of doppelgangers being a rare thing, which I think has been some of the kind of arguments for why we're perhaps overestimating innocent suspect ID rates in a lab. And people kind of have made this argument that what are the odds that you're going to have a very similar innocent suspect. I'm sure I've read some stuff though where they've made exactly that argument that, well, actually there are routes to becoming an innocent suspect that could make that much more likely than others.
Yeah, it's really interesting. Thank you.
I don't know, there's a couple more questions, but I don't want to hog the floor. So I don't know if any of the other speakers, if anyone wants to throw an additional question their way as well.
Let me just change my view so I can see you all. Yeah, open the floor. I guess we've got about 5 minutes until the other session starts. So I imagine session one apparently is having a quick break. I'm happy to have a quick break or continue with questions however people see fit. If people have questions for the other speakers they didn't have a chance to ask as well, now would be a fine time to do that. So thank you, Ruth. We'll see. In the meantime, Ruth, do you want to answer Liam's question? Or
I'll go for Liam's question as well. So Liam has basically kind of suggested that looking at who they pick, so when they've picked a filler, have they picked the same filler each time and those sorts of things. That is absolutely something I intend to do. I just literally haven't had the time since this data is so brand new. It was newly hatched last week. So I've only done the bare minimum around other work commitments. But yeah, I really want to look at who they pick, whether they are consistently picking the same filler because actually one reason why that might be really important is, that's a good point, there is kind of a proxy measure of, you know, ability to actually match across different instances, but also I think we may be underestimating the number of times an innocent suspect could be consistently misidentified, because it might well be that it might not be happening often with our innocent suspects, but maybe it does happen with a filler in a target absent lineup or something like that. So almost doing kind of a worst case scenario type analysis. But to do that, I do need to work out which filler was in which position and matched how, and it's going to be a bit of work, but it's definitely something I want to do with data.
Any other questions for any of the other speakers from anyone?
So Nick Tonks has an interesting question about kind of, and I guess this is probably can be answered by any of our ID people in the room, not just me, about the kind of the two-dimensional images versus the kind of real 3D real world experience of a witness. So Ryan Fitzgerald has done quite a lot of research on this stuff, looking at kind of live versus video versus photo lineups. I wish he was here to answer that question, because I think he's probably a far better person than me to answer it. But my understanding of that literature is that there's a surprisingly little difference in outcomes, especially when you consider the additional costs of things like a live lineup, where you might think all those cues from the body and the gait and everything else doesn't seem to help that much, which I'm guessing is people probably rely so heavily on the face. Anyway, I don't know. I don't know if anyone else wants to chip in who maybe knows that stuff better than me.
I love that we put you on the spot here, Ruth.
I don't know.
I hear there's another paper from Ryan. I think there's another paper from Ryan coming soon. I know he was still working on this stuff.
If I can just jump in, I think that's. I think I've been writing that paper.
Yay! Thank you.
Yeah. Yes, basically, there's no life benefit in any of the 3 experiments that we conducted for show-ups or lineups, and we think, and it is kind of in the data, that there is a benefit between photo and video, but we didn't test it explicitly, and we didn't plan to in that experiment. The experiment I'm talking about, it was really photo, video, full body, as well as head and shoulders and life, and there's no life benefit, but we did see full body benefits in our other experiments. So it doesn't seem that the 3D experience matters, so life doesn't matter, but the body and the face may matter.
And Melissa, I know you've done some stuff, Melissa, haven't you, on different like matching poses between encoding and test?
Yeah, with Heather, we found basically that if you match what the witness saw at encoding and what the witness saw at test, it boosts discrimination accuracy, which kind of has been tested a lot in the face recognition literature, but not so much in the eyewitness ID literature. So it's good to know that those effects carry over both. I can see that we do have to go now to the other session, but there's lots of interesting cracks. It's so interesting. Wayne Collins, who's a director of BIPA, has popped in the chat that in an old database there was a 1 doppelganger for a member of his staff at 1 to 54,000 chance. So it does happen even in BIPA. Right, thank you very much, everyone. I'll end the session there, but I would love to carry on. This has been brilliant.